Okay, welcome to 1.3. We're going to be talking about how to solve absolute value equations. Absolute value equations, what are the two bars called around the number sign? Well, they're called absolute value bars. Basically, the gist of absolute values are they make any value put in between the two bars positive. So any number put inside those bars comes out positive. How many different numbers can I put between the bars to make the following mathematical sentence true? So absolute value of what number equals 7? We know the obvious one, right, would just be 7. Another obvious one would just be -7, right? If we make -7 positive, won't it always be +7? Yes. And then we could also throw in some fractions. For instance, 14/2. We know that simplifies down to 7, right? Or -14/2. And we could keep going. There are a million mixed numbers that would equal 7 if we simplified them down. But just know that anything in those bars comes out positive. Okay, so now we're going to talk about how to solve an equation that has absolute values. So it's going to be very similar to solving a regular equation, but some added steps. So the first step is just to isolate the absolute value. So just like our goal of solving a regular equation is to isolate x, we are isolating the absolute value first. And then we just go from there. After that, we'll split it into two problems. A positive problem and a negative problem. So I'm just going to put that in parentheses. Solve it just as we would solve any other equation, and graph it. And I'll show you how to do that. And then the last step is to check for extraneous solutions, and we'll talk about what that means here in a second. First two examples, so let's first look at example 1. So our first step is just to get the absolute value by itself. So we have absolute value of 5x minus 4 minus 3 equals 8. So to get it by itself, we know we need to add 3 on both sides. So I now just have absolute value of 5x minus 4 equals 8 plus 3, which is 11. Okay? Next step is to split this into two problems. So I'm going to split it into a positive problem and a negative problem. So I'm going to leave what's inside the absolute value alone, but I'm going to get rid of the bars and set it equal to positive 11. The next problem, again, leave everything inside the bars alone, but get rid of the bars. But now it's going to be a negative 11. And now I'm just going to solve these two equations. I'm going to end up with two answers, okay? But solve them just as normal. So I'm going to add 4 on both sides. 11 plus 4 is 15 equals 5x. Last step is just to divide. And I end up with x equals 3. Same thing over here. Negative 11 plus 4 is negative 7. Divide by 5, and I end up with negative 7/5. Just going to leave it as a fraction. Okay, so I have these two answers now. X equals 3 and x equals negative 7/5. And now I just need to check them for extraneous solutions. So what that means is I'm going to take my calculator, okay, and I'm going to go plug both of these numbers back up into our original problem before we split it and see if they check out. See if what's on the left equals what's on the right. So if I plug in 3, so 5 times 3 minus 4, I end up with 11, right? Because 5 times 3 is 15 minus 4 is 11, so that one works. And then if I type in my calculator, 5 times negative 7/5 minus 4, I end up with negative 7 minus 4, which is negative 11, but take the absolute value of it, it's positive 11. Okay, I'm good to go. Both these answers work. So I've checked them. Now it's time to graph them. How I'm going to do that is just put them in order on a number line, least to greatest. So I know -7/5 is less than 3, so 3 is going to be over here, -7/5 is going to be on the left. And then I'm just going to do a closed circle dot right above it. And all that means is that those are my answers, okay? That is how I graph that. All right, moving along to example 2. And then going to erase so we have a little bit more space here. Okay, first step, isolate the absolute value. We end up with 3x minus 5 equals 7. Time to split. 3x minus 5 equals 7. 3x minus 5 equals -7. Time to solve. Add 5. Add 5. We end up with 3x equals 12. And then divide by 3, x equals 4. Got answer 1. Go ahead and solve for answer 2. Okay, now go ahead and plug both of these in and see if they both work. We're plugging them into the original. And if you check them, they both check out. So again, use a calculator on that. Makes it a whole lot easier. And those are my circles. Good deal. Moving right along to examples 3 and 4. Okay, let's look at example 3 first. Go ahead and try this one on your own. So pause here, try example 3 out. Okay, you should have added 5 on both sides. You end up with 4x minus 3 equals 7. Time to split. 4x minus 3 equals 7 and -7. Time to solve. X equals 10 over 4, which I know simplifies down to 5 over 2. Divide by 4, and x is -1. Okay, time to go plug into my calculator. You can hear mine here in the background. 4 times 5 over 2. And again, to type in a fraction, you use that ABC button if you're using a TI-30X calculator. So 4 times 5 over 2 is 10, minus 3 is 7. 7 equals 7, so we're good. 4 times -1 minus 3, so -4 minus 3 is -7. And the absolute value is 7, so we're good on that one too. Time to graph which one is less, the negative, right? And then I'm just going to plot these circles. You can draw them a little bit above or just on the number line works too. That's probably a little bit more accurate than writing it above. And we're good on that one. Try number 4. Pause here. Okay. Hopefully you got this far. This one's a little bit tougher, okay? So just as if this were a variable, let's just pretend it was x, how would we solve this equation? Well, if we had our equation house, right, that first level is subtraction, so make sure that you subtracted this 5 first. You'll end up with 2 times x minus 7 equaling 4. I still have this 2 out front though, and I'm trying to isolate the absolute value. So just like if I had 2x, I would divide that 2, right? So I can do the same thing here. Divide by 2, and I end up with x minus 7 equals 2. Now I've isolated that absolute value. It's time to break it apart. Okay, add 7, x is 9, add 7, x is 5. Okay, plug these in. So we're going to go up just to this one, okay? Go to where you broke it apart. That makes it a lot easier. And plug it in. So 9 minus 7 gives me 2, which works. 5 minus 7 gives me -2. Also works. Time to graph it. 5 is obviously less than 9. Close dot, close dot. Okay. Last two examples here. Example 5. We see our first step is we need to subtract that 11. We end up with 2/3 minus 4 equals -8. Little typo here. This was supposed to be 2/3 x. Sorry about that. Probably made it a little harder to solve, right? You might have thought it was way too easy just doing 2/3 minus 4 and adding 11. We'll go ahead and break this one apart. So 2/3 x equals negative, 2/3 x minus 4 equals -8. 2/3 x minus 4 is going to be a -8, which we know two negatives make a positive. Okay. Time to solve. Let's kill that fraction first. I know that comes first. 3 times 2/3 x is going to give me 2x. Again, I picked 3 as my common denominator because that was my only denominator. 3 minus 4 is 12. And then, 3 times -8 is going to be -24. Same thing over here. 3 times 2/3 x is 2x minus 12 equals 3 times 8, which is 24. Good. Add 12 on both sides, we end up with 2x equals -12, so x is -6. We then get 2x equals 36, divide by 2, and x is 18. Now time to go plug these back in right up here. So if I use that calculator, first one, 2abc3 times -6 gives me a -4 minus 4, which gives me -8. Is the absolute value of -8 though? Is it -8? Nope. It's not, right? That one doesn't work. And now what about plugging in 18? So 2/3 times 18 gives me 12, minus 4 gives me 8. Is the absolute value of 8 -8 though? No, it's not, right? Because +8 can't equal -8. So neither one of these answers work. So I don't have anything to graph on this one. No solution, right? Next one, my absolute value is already isolated, so that worked out good. I can go ahead and just split it into two problems. So 2x plus 5 equals 3x plus 4, sorry. And then we have 2x plus 5 equals -3x plus 4. Go ahead and solve. So this first one, we got to get it down to one variable. We're going to subtract the 2x. We end up with x plus 4 is 5. Subtract the 4. We get x is 1. Next up, we got to distribute out this negative first. So that's going to give me -3x minus 4 equals 2x plus 5. My smaller variable this time is 3x, so I'm going to move that over. Subtract 5. 5x equals -9. And then last step here, divide. And I'm just going to leave it as -9/5. Okay, time to go back up to plug it in. So we're going to try to plug it in up here and see if this works. So let me erase this 18, which is coming over from the other side. Okay. So we've just got 1 and negative 9/5. So let's try 1. So if I plug it in on the left side, so 2 times 1 plus 5 is 7. Plug it in on the right side, 3 times 1 is 3, plus 4 is 7. So that one works. Next one, plug it in on the left, 2 times negative 9/5 plus 5 gives me 1.4. Okay. And then let's try the next one. So 3 times negative 9/5 plus 4 gives me negative 1.4. So those two things don't equal each other. So negative 9/5 is not going to be a solution to this one, but 1 is. So if I graph that, that's what it looks like. So that is how we do these. Make sure you check Canvas for homework and let me know if you have any questions. Thanks, guys. Bye.